Okay, so this was the equation of the given. I have already calculated the y-intercept and the x-intercept. Guys, usually that would be where we would stop, right? We have the y-intercept and 2x stop. But now, in grade 11, we also have to calculate, because remember I said yesterday, the y-intercept is not necessarily the turning point. We actually have to calculate the turning point as well. Alright, so often when we're drawing parabolas now, this year we're going to have 4 points. Okay, so that's an extra step that we haven't done before. Now, when you have a parabola that's given in standard form, right, there is a different method actually for you to find the turning point. Alright, you don't have to write the equation in turning point form first and then get the turning point. You can do that if you want to practice that in a step, right? That's completing the square thing. But what you can also do is you can use the turning point formula. So I'm just going to write it here. It is on that note that you got 2 days ago, but we obviously need to practice it. So the turning point formula is it. And this is something that you're going to have to remember off by heart. You're going to have to memorize this formula. You are first going to calculate the x coordinate of the turning point. Okay, and to get the x coordinate, the formula is negative b over 2a. And remember that b and a, those refer to numbers in this equation. So go back up to our equation again. This is the equation, right? A, remember, is always the coefficient of x squared. So a is 1. You can add that in there. A is 1. My b value is always the number that's in front of x. So b is 5. And then c is your y-intercept, your constant term, c is 6. Okay, I'm sorry. If an equation is written in standard form, that will always be your a, b, and c. Okay, a is always the number in terms of x squared, b is the number in terms of x, and c is the constant term. So now when we're doing negative over 2a, we're going to do negative 5 over 2 times 1. Okay, so we're using the b and the a values from the equation of the graph. Okay, so x is going to be negative 5 over 2a, but a was 1. You get those values from the equation. Then you just need to simplify that. Can't really do much with that. You can just write it as negative 5 over 2. Which is negative 2 and a half. Okay, so that is the x value of our turning point. Now, remember, a point has an x and a y value. So we still need to find the y value as well. So once you found your x value, you're going to take this x value and you're going to sub it back into the equation of the graph. That will give you the y value. Okay, so I'm just going to write here underneath the turning point formula. You get your x value, then sub into equation to get y. So we're going to say y is equal to, and we remember the equation was x squared, so it's now going to be our x value squared plus 5x, right? So plus 5 times our x value, and then plus 6. So you take the equation of the graph that they've given you, and you just put in the x value of the turning point where it is. Yeah. We multiply that Yes, so if there was another value, it's 2 times the magnitude. But you just type it into the calculator. Plus 5 times negative 5 over 2, and then plus 6. Okay, so you just type that into the calculator, and you will get an answer of negative a quarter. Okay, so that means, guys, that our turning point is the point negative 5 over 2 and negative a quarter. Okay, those are the coordinates of the turning point. Now, if we go back to the work that we did yesterday, we actually did this as an example where we wrote this equation in turning point form. I'll just go back quickly to show you guys. The equation was y equals x squared plus 5x plus 6, right? And yesterday we did, no, we looked at, am I imagining this? I think we did. Sorry, no, I'm imagining it. Didn't we get one with negative 5 over 2 and a quarter? Sorry.
This was negative 5 over 2 and negative a half.
Oh, because we have the 2 that we lost that in. Okay. Yeah, thank you. Okay. Sorry about that, guys. Never mind. Okay, that is the turning point there. I now want you guys to draw this graph, please. Let's quickly look back at all the information that we have. We actually have 4 points now. We have a y-intercept, a 6. We have 2 x-intercepts, right? One at negative 2 and one at negative 3. But guys, even that is a bit odd, right? Normally, in the past, when we did parabolas, we always got one negative x-intercept and one positive x-intercept. That's because the turning point was always the y-intercept. So the y-intercept was always like in the middle. Okay, what is now the turning point? This one over here. So this is going to be like your middle point. All right, negative 5 over 2 and negative a quarter. Guys, if you want to, you can rewrite this as negative 2.5. That would be easier to plot. And negative a quarter. We're going to have to plot those 4 points first and then figure out, maybe circle the turning point, right? So that you know that is the one way to point the turn. And then you're going to have to figure out what that graph is going to look like before you actually get it. Okay, do that quickly, please. You have your 4 points that you must plot. I'm going to run it from here quickly. This throat. Okay, so I don't really do mine to an exact scale. That is my y-intercept, right? Okay. This would be my turning point, negative 2.5 and negative a quarter. And then there I have my 2 x-intercepts, negative 3 and negative 2. Okay, so now, just pretty quickly, you guys get an idea of how this is going to look. It's going to go up through there and then go up on that side as well. Okay, so that turning point is always the middle of your graph. Okay. I just closed the whole thing. Okay. That looks a bit wonky now. Okay. Okay, something like that. Right? These guys, just remember to label all your points. So, this is 0, 6, turning point. And then your two X-intercepts, negative 3, 0, and negative 2, 0. Okay. Are there any questions about drawing that graph? And calculating any of the points? Are you guys okay with that? Yeah, I just want us to discuss a few other things as well, because obviously you're not just going to be asked to draw these graphs, you can be asked to concentrate on about them as well. So something that, I'm not sure if you discussed it last year, but we do need to talk about it now, is the axis of symmetry of a parabola. You might have heard of it with parabolas, maybe not with parabolas. Now guys, the axis of symmetry is a line that when you fold the graph over that line, it basically fits, the two halves basically fit on top of each other. So it's a line that will cut a graph in half. Now for a parabola, I want us just to add it here at the bottom. The axis of symmetry axis of symmetry and this will always be the case when you can memorize this. The axis of symmetry is the x value of the turning point. The turning point is always in the middle of the graph. Okay, and the graph is symmetrical on either side of that turning point. So if they're asking me for the equation as the axis of symmetry, it's always the x value of the turning point. Now, what was the x value of our turning point? Over here, hey, negative 5 over 2. So for us, for this graph, the axis of symmetry is x equals negative 5 over 2, just like that. Okay, we're going to write x equals, and then the x value of the turning point. We're also going to draw it in on the graph. So I would like you to take your ruler and to draw a dotted line going through your turning point, and it's going all the way up and all the way down. Okay, so it is literally going to be a straight line. You can make it dotted. I'll do that now. Going through your turning point. Okay, like that. And then you can just make a dotted line. See? Yes. That. And then like save now, we need to label it. So just, you can either write it at the top or the bottom. I'm gonna write it at the top because at the bottom I already have something written there. I'm just gonna write x equals negative 5 over 2. So that is the equation of that line. All right. Okay, something else we just need to talk about quickly is domain and range. I think we did discuss it when we spoke about trig graphs, and obviously it comes into play here as well. So I'm just going to write at the bottom just a reminder of what the domain and the range actually are. So domain is the set of all x values on your graph. what you're going to do is you're going to look at your graph and you're going to ask yourself which x values will fall on this graph. Okay, even if we can't see it on our graph, we know that we have arrows, so we need to be able to visualize what's going to happen there. So if we're looking at our graph, what do we think? The x-axis is this one, right? So we're basically looking to the left. Where is this graph going to end? Is it going to end? No, right? Because we have an arrow. So what's going to happen is that graph is going to keep doing this forever and ever. Okay. So to the left, it's not going to end. And also to the right, we also have an arrow, so it's not going to end there. So it's going from negative infinity to positive infinity. Okay, there are different ways in which you can write that. I'll write down the different ways now. So you can say x is an element of negative infinity to positive infinity if you want to. Remember that whenever we are writing infinity or negative infinity, we have to use round brackets. Okay? Or you can also say, which is quicker, you can just say x is an element of all real numbers. Okay? Real numbers or all numbers that exist from negative infinity. Okay, so you can write it in either one of those two ways. Then the range is when we're talking about the set of the y value. Okay, so if we're looking at our graph, now we're going to be looking up and down, right? That is how we read our y values. So guys, is this graph going to cover all y values? No, okay, it stops there. The lowest y value that it is going to have is at that turning point. What is the y value of this turning point? Minus a quarter. Okay, going up, yes, it will carry on to infinity because we have arrows. Okay, but the lowest y value that it can have is the y value of that turning point. It won't ever have a y value that's smaller than negative. Okay, your parabola is not going to turn back and go back down. So we need to write somehow, I'll show you now how to do that, that y is all values greater than and including negative. Okay. There are different ways of writing it, so you can say y is greater than or equal to negative a quarter if you want to, just like that. That's fine. Or you can say y is an element of, now the smallest y value, like we said, is negative a quarter, so you write the smallest value first always, but because there's actually a point at negative a quarter, we have to use way bracket. And then that will go all the way up to infinity. And we remember for infinity always around that. Okay. I'm just going to do an example of drawing a parabola where it's given in turning point form, so you can see how that works. And then I'm going to make you guys practice some on your own. And I just want to get one that's not too hectic. And I'll just check the fix what this is. One. Okay, so this will be example 2, guys. You can remember it. Okay. Oh, sorry. Okay. Here we go. Y equals negative a half, and then in brackets, x minus 4 squared, and then plus 2. So what are we going to do now? Alright, so as soon as we see that squared bracket, you need to think turning point form. Okay, remember turning point form, I'll just write it here on the side. Was y equals a bracket x minus p squared plus q. And that is what turning point form looks like. Alright, do we agree that it's the same thing? And our a value now is negative a half. Now the fact that it's a half doesn't matter. Okay, don't stress about that. I think it makes this equation look much more complicated than that. Okay, not that bad. We need to identify though that it's negative. So that means that we're going to have a downwards facing point here. And guys, this is a nice check. All right, once you've plotted your point and you've drawn your graph, and you actually are ending up with a graph that is an upwards facing one, but your a value is negative, that is maybe a way of just figuring out that you made a mistake. Okay, when you maybe calculated some of your points, you did that incorrectly. So this, you don't really use this so much other than to kind of check with your graph. Yeah. Alright, guys, the turning point, remember, we get from the p value and the q value. Right? So what is my p value in this case? X minus p squared and x minus 4 squared. 4. Right? Remember the sign in the bracket is different from the sign in the turning point. Right? And then the y value, that sign is going to be the same. So we can say straight away that our turning point is 4, 2. And that's the nice thing about when an equation is given in turning point form. You don't still have to go calculate that whole x equals minus 0 to 2 x. All right, you can just read off what the turning point form is. Unfortunately, we can't read off our y-intercept and our x. Okay, those we now need to calculate properly. So for the y-intercept, I don't know if you guys remember this, but to find the y-intercept, if you can't read it all from the equation, you have to make x equal to 0. Right, and then work that out. Make sure that you're writing that out. Guys, you can only read off the y-intercept if it's standard. Okay, this is not the y-intercept, right? This is the y value of turning point. Okay. In the previous one, the equation was given in standard form, so the y-intercept was our c value. Okay, our constant term. When it's given in turning point form, it's different. Okay, so please don't make that mistake. For the y-intercept, we need to make x equal to 0. You can just do that on the calculator, but let's just write it out for now. Since it is the first example, you know. So I'm just writing that whole equation, and in the place of x, I'm going to use a 0. Okay, that's all we need to do there. We have 0 minus 4 squared plus 2. Right, you can just type that into the calculator. It will give you an answer of negative 6, yeah. Negative 6. So our y-intercept here is 0, negative. Okay, for the x-intercept, we do the same thing as for the previous one. We are going to make y equal to 0 in our equation and then solve for x. So I'm going to show you guys a quicker way of solving for x now when it's in turning point. Okay, we're not going to have to factorize. So you're going to make your whole equation negative a half bracket x minus 4 squared plus 2 equal to 0. Guys, if you want to, you can multiply those brackets out, multiply the negative a half in, simplify, factorize, get your two brackets, make them equal to. Okay, but that's quite long. Because you first have to multiply out before you can factorize. In the previous example, it was already a trinomial that we could just factorize straight away. Okay. Or remember, I said if you didn't want to factorize here, you could have used the quadratic formula. But remember, to use the quadratic formula, you have to have it multiplied out as well. Okay, so I can't look at this equation now and say, oh, I'm going to use the quadratic formula straight away. Right? You would first have to multiply all those brackets out and simplify. So what I'm going to do is, I'm actually going to move this plus 2 over to that side. What's it going to become on the other side? Negative 2. Okay? Okay, next, I'm going to get rid of this a value. What am I doing with this a value on this left-hand side? I'm multiplying by, right? So when I move it, I'm going to have to divide by. I'm going to say negative 2 divided by negative a half. Okay. All right, I'll see you on the side as well. You're going to be left with this. We're going to do negative 2 divided by negative a half, which is actually positive 4. Now I'm just going to write there how we got that. Negative 2 divided by negative a half. You'll obviously just use the calculator for that, guys. Don't stress. Okay, but then we'll get 4. Now, next, we're going to move that square over to the other side. Does anyone remember what the opposite is of squaring? Square rooting, but remember, what must you do? There's something that you must remember. You can't just square root, you have to do a plus or minus square root. Remember, that's what we're doing. Okay, so plus or minus the square root of 4. Again, try 2 straight away, but I didn't want to do that. Okay, so you're actually getting x minus 4 is equal to plus or minus 2. Now, what's the opposite of subtracting 2? Adding 4. So all I'm going to do now is I'm going to add 4 to the other side. Now that looks very strange, right? But what that means is you're going to get 2 answers. Do we agree that we're supposed to be getting 2 answers here, guys? Right? So if you forget that plus minus, you're only going to get 1 answer, which means you're only going to get 1 x-intercept. So your parabola is going to look funny. Okay. So you have to remember that plus minus. Maybe highlight it. And that's very important. Now what this means, guys, is you're actually going to be doing 2 calculations. So you're going to have x is equal to positive 2 plus 4. Or just 2 plus 4, right? We don't normally write that plus. That's the number. So that will give us our 1 x-intercept, which is 6. Okay, but remember this plus or minus means literally positive or negative. So we're going to get our second x-intercept by taking the minus with that 2 and then adding 4. The negative 2 plus 4, which is what? Okay, so there we are getting our 2 x-intercepts. 6, 0, and 2, 0. So guys, that's just a different way. I think an easier way, it might look a bit longer because it has like lots of steps, but I think you may be less inclined to make mistakes if you do it like this. Or I'm going to write on the side, or multiply out and use quadratic formula. You're more than welcome to do that if you want, guys. I just wanted to show you different ways. Okay, we have 4 points, guys. We have our turning point. We have our y-intercept. We have our 2x-intercepts. Please draw this graph quickly. Put it on your own. And remember, it's supposed to be a downward spacing. Okay, that could also possibly help with the actual drawing of it, if you remember that. Okay. Anyway, you get the idea. So I'm just going to x-intercept y-intercept. And then I just want you guys to draw in the axis of symmetry again, please. Remember, the axis of symmetry is just a straight line. You can make it dotted going through that turning point. And then we're going to write the equation of it as well. And what would the equation of this axis of symmetry be? What do you guys think? X equals 4. Good. Remember, it's always the x value of the term. Okay, so you can write it at the top if you want, or at the bottom, wherever you feel you have enough space. Okay, we're going to write the domain and range just underneath this graph. And just like this. Okay, we remember domain is all the x values. What do you think? What's the lowest x value going to be? Negative infinity. Okay, we have that arrow, and the biggest x value, positive infinity. Okay, good. So you can again write it in either notation that we used before. Everyone you remember, whichever one you prefer, everyone. Now, if we're looking at the range, do we have the lowest y value in this case? It's going to be negative infinity, right? But we do have a highest y value in this case. All right, in the previous one, because it was an upward facing parabola, we had a minimum point. Our turning point was the minimum. Now, because it's a downward facing parabola, we actually have a maximum point. Okay, so the highest y value of this graph is 2. So you can write y has to be smaller than or equal to 2, like that. Can't say bigger than 2, right? Because then you're saying that you have points above your turning. So you would have to say y is smaller than or equal to 2, or you can say y is going from negative infinity in this case to 2, which is way less. Okay, any questions, guys? Alright, I'm going to give you a few of these to draw on your own, 2, I think, on the weekend. I'm going to just copy that down because I need to write it down for you. Okay. Okay, so I'm going to give you one that's written in standard form and then one in turning point form. So let's call the first one altered x, which is just the same as y, right? Don't have to doesn't change anything. Let's do negative x squared. Wait. Sorry. Okay. And negative x squared. X squared times 4x minus 6. Okay, so that one is in standard form, so you're going to look at the first example that we did. Okay, and just basically do all those same steps. And then the second one is going to be g of x. And again, sorry, I just want to make sure that it's not one that is two, like that. And the second one is the third one for us, so you're going to use the second example. Right, please start on that now, guys. You have 6 minutes, you can only do the first one.